So imagine a scenario where you're extremely bored in math class to the point where you're about to fall asleep, or you may have already fallen asleep, and this is you. So your teacher decides to call you out for not paying attention, and you're like, why do I have to listen to you constantly drone on about this subject that I couldn't care less about? But you don't actually say that, you just think that to yourself. So you ask to go to the bathroom, and your teacher actually decides to let you do that, which is a mistake. But she lets you, or he lets you, go to the bathroom, and this is you. And you didn't get much sleep that morning, so you accidentally stumble into the janitor's closet when you're actually trying to go to the bathroom. And in front of you, you see what looks to be about 17 boxes. You actually count each of them out because, why wouldn't you? You're in the janitor's closet and you have nothing better to do. So you look closer and you see that it's boxes of erasers and pencils, right? And you see that each of the boxes of pencils have 12 pencils each, and each of the boxes of erasers have 5 erasers each. And so let's actually write that down right now. So each box of erasers has 5, and for erasers I'll put an E. And each box of pencils has 12. For pencils I'll put P. And you know that in total you have 17 boxes. And as you're going out of the janitor's closet to actually go use the bathroom, you stumble into the janitor himself, and he says, "What the heck were you doing in there? I had to go transport my stock of, we'll say, 134 items and distribute them evenly between a bunch of classes." And you're like, okay, cool. So you say bye to the janitor, you go do your business in the bathroom, and you go back to math class. And you decide to try and make a calculation of how many boxes of erasers were there versus how many boxes of pencils were there, because you'd rather do that math problem than the boring math problem that your math teacher is presenting to you. So you know that you have 134 items in total. So let's also write that. And this includes erasers and pencils, nothing else. So using all of this information, how can we possibly craft us some equations that can help us find our missing values? So in order to do that, we must first ask ourselves, well, what are our missing values? And apparently it's the number of boxes of erasers and the number of boxes of pencils, because although you decided to count them all together, you forgot to count each of them and see how many of each were there. So we'll say that our hidden values are the number of boxes of erasers and the number of boxes of pencils, and to represent those hidden values, we can use variables. So you already have a variable here for erasers, E, and we already have another variable for pencils, P. So let's already use those, or let's use those that we already established. So we know that we have 17 boxes in total, right? So we can write the variable E, and E represents the number of boxes of erasers, while P represents the number of boxes of pencils. And if you were to add both E and P together, because those are the number of boxes of each erasers and pencils, you would get 17, because there's 17 boxes in total. So already we have come up with an equation for ourselves that can help us maybe solve for one of these variables. But however, we can't just use this equation alone, because there's two variables in an equation, and as you may know, you can't solve for one variable in an equation when you have two. So maybe we can come up with another equation. So we know that there are 5 erasers in each box and 12 pencils in each box. So maybe if we use those numbers as the coefficients, then we can add them together, possibly get 134 items. So let's do that. So 5E and 5 being the number of erasers in each box. And 5e as a term represents the number of erasers you have in total, right? Because that's 5 multiplied by the number of eraser boxes. And then we can add that to 12p using the same thought process that we used for the erasers, because there's 12 pencils in each box, and we have p number of pencil boxes, and if we were to multiply those two together, then we would get the total number of pencils that we have. So if we were to add the number of erasers we have to the number of pencils that we had, then we would get the number of items that the janitor told us that he was distributing to those classes, which is 134. So now we have two equations right here. And essentially, this is called, what we just made, a system of equations. And with a system of equations, the interesting thing is you can actually evaluate both of these by combining them together and then finding the value of both variables that are in both of the equations. So after I show you what we're going to do, you'll be able to solve for both E and P. And to connect a system of equations and show that they're actually a true system of equations, what you do is connect them with a bracket, as so. So there are three different ways you can go about solving a system of equations and getting your two variables. There's actually other systems of equations that have 3 and 4 variables, but those we'll get into in much later videos. But I digress. There are 3 methods you can do here. There is elimination, there is substitution, and there is graphing. So I'm only going to show you one of those methods in this video, which is elimination. In my next video, I'll show you how to solve a system of equations using substitution, and I'll show you how to do one using graphing. But right now we're just going to use elimination. And in the method of elimination, what you're aiming to do is, in the name really, you're aiming to manipulate one of the equations so that you can eliminate one of the variables after combining both equations together. After you eliminate one of the variables, then you can solve for the remaining variable, and you can plug that value back in to find the variable that you eliminated. So that might have sounded like a lot, but we're going to do it right now to clear things up. So first, what you want to do is manipulate one of the equations so you have a matching term. So I want to have a matching term of 5e because 5e is less than, or 5 is less than 12, and it makes the multiplication a lot easier since we're multiplying by a smaller number. So we're going to begin manipulating by multiplying this first equation by 5. So if we do that, we would have to multiply everything by 5. So then it would become 5e plus 5p. So 5 is being distributed to every term in the equation equals, and 5 times 17 is 85. I'm going to do that in green. And now we have manipulated our first equation successfully, so we can start to combine this manipulated equation with the second equation. And we'll leave the second equation the same because we already have our matching term of 5e. So I'm just going to rewrite it down here. 5e plus 12p equals 134. Okay, so now that we have our two equations, we can connect them again. Essentially, this equation is literally the exact same as this one, except it's multiplied by 5 so that we have that matching term. and we made sure to manipulate it on both sides so that it actually stays the same equation. So now that we have this matching term, we can begin to eliminate. And this is I would say, the most crucial step in solving this. So to eliminate, we're just going to subtract this entire second equation from the first equation, because you can't just pick and choose what you want to subtract. You can't just say, okay, let me eliminate the 5e, let me add the p's, and then let me divide the uh, we'll say solutions. You can't really do it like that. You would have to subtract the entire second equation from the first equation. So we're going to start by doing 5e minus 5e. Once you do that, then the 5e's become eliminated, and then we have to do 5p minus 12p. You can sort of think of it like the minus sign is being distributed to every term in the second equation. So you might want to change this positive sign to a negative as such. So 5p minus 12p, that's negative 7p. And that is equal to, now we're going to do 85 minus 134. Let me draw a subtraction sign here. And 85 minus 134 comes out to be 15, 49. So that's going to be negative 49. Now we can divide both sides by negative 7 so that we can isolate our p. After doing that, we get the answer p equals 7. So now we have the answer for the number of pencil boxes we have, and we got 7. So we have 7 pencil boxes make up those 17 total boxes. So from here you can sort of see that the remaining number of boxes is 10, and say, hey, well, so we have 10 eraser boxes, right? And you are right, but say you had a more complex example and you actually had to calculate the number of eraser boxes, but you couldn't do that simple mental math. Well, really what you do here is you take the value that you got for the variable that you solved for. So in this case, we solved for p first, and then you're going to plug that back into one of your original equations, right? And normally what you would want to do is plug it back into the simpler of the two equations. And in this case, the simpler equation in our case would be e plus p equals 12. So let's plug in the p value that we got into this equation, and after we do that, then we can solve for e. So the equation will now be e plus 7 equals 17. So now to solve for e, it's really quite simple. You just subtract from 7 on both sides so that you can isolate that e. And after doing that, eliminate the 7, and you get e is equal to 10. So there you have it. You finally found that you have 10 eraser boxes of that pile and 7 pencil boxes. So essentially that is how you solve a system of equations using elimination. And in the next video, I will demonstrate to you how you can solve systems of equations using substitution and using graphing. So thank you for watching, and I'll see you in the next one.